Okay, today we are going to do Objective 16. We are going to solve quadratics by the quadratic formula. And I'm going to tell you that please really try to pay attention to this lesson because graphing is great, but it doesn't give you every answer you need. So you can't do graphing every single time, okay? Factoring is great when things are factorable. Not every problem is factorable, and it only gives you real answers. The quadratic formula will give you real answers. It'll give you imaginary answers. The quadratic formula is a surefire way to get every single problem correct. So if I was going to put my eggs in a basket, I would either put them into today's lesson, quadratic formula, or I would put them into tomorrow's lesson, which is completing the square. Because those two ways will get you every answer every single time. So we're going to make sure we need to know this. So here's your formula, and I always sing a little song when we do this, and we say, me. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And so there is your quadratic formula, okay? X equals negative b plus or minus the square root of b squared minus 4ac all divided by 2a, okay? And everybody says, okay, that's fine and that's dandy, as long as we know what a, b, and c are equal to. So when you're looking at a quadratic equation, it will be in this form. Ax squared plus bx plus c is equal to 0. Okay, so step number 1, you got to set it equal to 0. The a will be the coefficient or the number in front of the x squared. The b will be the coefficient or the number in front of the x. And the c will be your constant that's at the end. Okay? So, I have a really easy way of doing the quadratic formula, and we do it into sections, okay? So what we do first is we find the discriminant. The discriminant is what goes under the radical, the b squared minus 4ac, okay? That is what you call the discriminant. If the discriminant is a positive number, let's think about this. Let's just say the discriminant is the square root of, give me a positive number, square root of 9. We know that there will be 2 real answers because we need to think about what is the square root of 9. What times what could equal 9? It could be positive 3 times positive 3. So square root of 9 could be 3. Or the square root of 9, it could be negative 3 times negative 3. Okay, so that's where you get the plus or minus. So that's going to create 2 different answers. Okay, that's going to create 2 different answers. It could be a positive 3 or it could be a negative 3. So with this shows us that they're going to have 2 real solutions. Okay, if the number under the radical is a positive. Okay. If the discriminant is a negative, so let's think about this. The number under the radical, let's come up with, I don't know, negative 4. What do we know about a negative under the radical? We know that that comes out as an I. And we know that the square root of 4, it could be positive 2 times positive 2. So this would come out as a positive 2i. Or it could be a negative 2i. So what does that tell me about my solutions? That I'm going to have 2, one positive, one negative, 2 imaginary solutions. So if my discriminant, if the number under the radical is a negative, that's going to tell me that there's 2 imaginary solutions. Then, if the discriminant, the number under the radical, is equal to 0, first of all, what's the square root of 0? 0. Will it have a plus or a minus? No, because there's no such thing as a positive 0 and a negative 0. So we know that this one will be 1 real, because it's not imaginary, real solution. So this is one that if you graphed it, it would just touch the x-axis one time. So just by looking at the discriminant, you will know whether it's going to cross twice, whether it's only going to cross once, and if it doesn't cross at all, we know that it'll have two imaginary solutions, okay? So that's how we're going to solve ours. So step number 1, is it set equal to 0? Yes. Number 2, what we're going to do is we're going to find our, let's label A, B, and C first of all. Let's figure out. So if it's in the right form, ax squared plus bx plus c equals 0. So we know a is equal to 1 because there's a 1 in front of the x squared. We know b is equal to 9, and we know c is equal to 20. Okay. So if I wanted to solve this, and here, let me say this too. I don't know if any of you are looking at this, but is this one factorable? Yes, because it could be x plus 4 and x plus 5, because that multiplies to be 20 and adds to be 9. So we know based on what we did yesterday that if the factors are x plus 4, that the answer is going to actually be x equals negative 4 and x equals negative 5. So I already know the answer to this one. I'm just going to show you, though, how to work it with the formula. So here's what I will tell you. You know, like if you look at something and you know it's easily factorable and you can do it in like 30 seconds, then do it that way. But the formula, this is how it works with that. Because you will need to know how to do the formula, especially for those imaginary problems, because not every problem is factorable. So what we're going to do is we're going to find our discriminant, b squared minus 4ac. So I'm going to plug in 9 squared minus 4 times 1 times 20. And you can put this whole thing in your calculator with parentheses. And 9 squared, if I did it by hand because I don't have a calculator on me, but again, you could put the whole thing in, you should get 1. 9 squared is 81. Then if you multiply next, because I'm using PEMDAS, negative 4 times 1 times 20 is negative 80. So when you subtract, you get 1. So I know x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So I know if I plugged in, first of all, this says negative b. So that means, sometimes I like to say the opposite of b. Because if my b is 9, when I plug in, it's going to become negative 9. Plus or minus, we've already done all this, so we know this is the square root of 1. All divided by 2 times 1, or just 2. So we can keep going. Do we know the square root of 1? What's the square root of 1? Square root of 1 is just 1. So this becomes negative 9 plus or minus 1 over 2. And now you can split it apart and make 2 problems. You would say one with the plus and one with the minus, right there and right there. So you could say negative 9 plus 1 divided by 2, and you could say negative 9 minus 1 divided by 2. That's how you're going to get 2 different answers. So negative 9 plus 1 is negative 8 divided by 2, which is equal to negative 4. And negative 9 minus 1 is negative 10 divided by 2, which is equal to negative 5, which I told you from the get-go would be your answer, because in my head, I just factored it. And I know some of you who are good at factoring can do it. But that's how you work it to get the same answer. And if I graphed it, it would work too. 1, 2, 3, 4, 5. It would be crossing at negative 4 and negative 5, and it would look something like that. Okay? So let's look at the next one. So my question to you first is this one factorable? Is there something that multiplies to be negative 18 that can add to be 11? And I'm going to say no. I don't think this one's factorable. And I know some of you are going 9 and 2, 9 and 2, but it's got to be one negative, one positive. So like a negative 9 and a positive, that would add to be 7 or negative 7. That's not going to be 11. So I don't think this is factorable. So you may have to do this one. Let's take a look. Let's label A, B, and C. A is equal to 1, B is equal to 11, and C is equal to negative 18. Okay, so make sure you carry your signs. And there's your 1 right there. So let's write our formula down. X equals negative B plus or minus the square root of B squared minus 4AC all over 2A. And I would write the formula every time. Okay, now let's take a break and let's go over here and let's work the discriminant. Let's see what that's going to equal out. Okay, so this is going to become 11 squared minus 4 times 1 times negative 18. So this becomes, and again, you can put this all in your calculator all at once. So if I do that, I'm just going to do that. 11 squared is 121. I know that. So 121 minus 4 times 1 times negative 18. And that's going to equal 193. Okay? So what do we know? That's a positive number, so will my answers be real or will they be imaginary? We know right now, because of this 193 is a positive, we know that this is going to have 2 real answers. Okay, 2 reals. So let's plug it into our formula. The opposite of B, so B is 11, so the opposite would be negative 11 plus or minus the square root of 193. All divided by 2 times 1, which is 2. And here's what I will tell you. Is 193 perfect? Like a minute ago, we had the square root of 1. So we took the square root of 1 and got 1, and we kept going. Is 193 perfect? No. Can you factor tree 193? And if you start dividing 193, like we know 2 doesn't work. If you try to divide it by 3, that doesn't work. 5 doesn't work. I don't think you're going to be able to factor tree 193 down. So here's what I'm going to tell you right now. You can leave your answer just like this. If it is perfect, if it is a perfect square, you got to keep going, like we did in example 1. But if it is not perfect, if you can factor tree it out and simplify the radical, then you want to do that. But I don't think you can factor tree 193 down, so you're just going to leave it. Okay? And that is 2 answers. And on the SOL, it might say, you know, what are your 2 answers? You could say one answer is negative 11 plus the square root of 193 over 2. And then you could say negative 11 minus the square root of 193 over 2. Okay? It's a plus right there. It's a really bad plus. Okay, so let's keep going. So what's different about number 3? Step number 1, you've got to set it equal to 0. So I'm going to pull 7 and over. And notice that I'm putting it where? He goes in the middle because you got to put them in order. Like you have your squared term first, then you have n to the first power, and then you have your constants at the end. Okay? So here's what I'd like for you to do. I want you to pause it, go as far as you can with the problem. That will help you know whether you're doing it right or wrong. And then then you can hit play and go from there. So if you're back with me, let's label A, B, and C. A is 1, B is negative 7, C is negative 120. So x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So let's work our discriminant, b squared minus 4ac. Make sure you put this in parentheses, negative 7 squared, because it will be different. If you just put in negative 7 without parentheses and square it, you'll get negative 49. We need the negative 7 to be in the parentheses so that it comes out as a positive 49. Make sure that is super duper important. Okay, and you can put this all in your calculator all at once. So I know negative 7 squared is 49. So 49 minus 4 times 1 times negative 120. And that gives me 529. My question to you, is 529 a perfect square? And it is. We know that there's going to be two solutions, because we know the square root of this is positive plus or minus 23. Okay, so let's go back to our formula. So the opposite of b, now if I stick in a negative 7, that becomes a double negative. So again, that's why I say like the opposite. So if b is negative 7, that's going to make your b here positive 7. The opposite of b would be 7 plus or minus the square root of 529, all divided by 2 times 1, or 2. So my question is, and this is where people get confused on, is like on the last one I stopped it right here. Is this one that I stop, or is this one that I keep going with? And I'm going to tell you, you have to keep going because he is perfect. So if he's not perfect, if he does not simplify, you leave it. But if he is perfect, you got to keep going. So we know the square root of 529 is 23. So this becomes 7 plus or minus 23 over 2. So then we make two problems, separate it out. 7 plus 23 over 2, and then 7 minus 23 over 2. It's not writing very well. Sorry about that. All right, so 7 plus 23 is 30 over 2, which is going to equal 15. And then 7 minus 23 is negative 16. Oops, over 2. It's not wanting to write there, which is equal to negative 8. So those are your two answers. So if it's perfect, you've got to take the square root and keep going and separate it out till you get to your answer. So if I graph this, this would be crossing at positive 15 and at negative 8 on the x-axis. All right, so let's keep going. For each one we do, I want you to pause it, try it, see how far you get with it, and then we'll go from there. So I'm going to label A, B, and C. So A is 4, B is negative 24, and C is 35. I'm going to find my discriminant. So this is going to be negative 24 squared. Notice I put the square on the outside. Times 4 times 4 times 35. And I'm going to put this all in my calculator and see what we come up with. So negative 24 squared minus 4 times 4 times 35. And I get 16. So x equals negative b plus or minus the square root of b squared minus ac all over 2a. So the opposite of b is going to be positive 24 plus or minus the square root of 16 over 2 times a, which is 2 times 4, which would be 8. So is this one that you leave, or is this one that you keep going? And I would say keep going because 16 is perfect. So we need to make the square root of 16 is plus or minus 4 over 8. So then you can separate it out. 24 plus 4 over 8 and 24 minus 4 over 8. keep going. This will be 28 over 8, which reduces to 7 over 4. And then this would be 20 over 8, which reduces to 5 over 4. So those are your two answers. So if you're going to actually write them, you could put them in a sets. X is equal to 7/4 and 5/4. My question is, what's y equal to? Y is equal to 0. So again, these are x's. I'm solving. I'm figuring out where it's crossing on the x-axis. And so that tells me it's going to be a decimal. Like 5/4 is like 4 and a fourth, so 4.25, so in between 4 and 5. 7/4 is 4 and 3/4, so about, or excuse me, 1 and a fourth, so in between 1 and 2. Sorry about that. And then 1 and 3/4, which is closer to 2. But it's going to be a decimal in between. Okay? A couple more. Let's see how this plays out. Keep pausing, try it, see what you get, and then watch. Check it. So let's do A, B, and C. So I need to make this equal to 0. Okay, so A is 1, B is -2, and C is 5. Let's do our discriminant. Times 5. So this would be 4 minus 20, which I believe is -16. So what does this tell us about, like if I took the square root of that, what does this tell us? Because my discriminant's a negative, that means I'm going to have an imaginary answer, because we know the square root of -17 or 16 is going to end up being plus or minus 4i, because the negative comes out as an I. Okay, so x equals -b plus or minus the square root of b squared minus 4ac all over 2a. So let's plug in. The opposite of b would be 2 plus or minus the square root of -16 over 2 times 1, which would be 2. So this is going to become, we got to keep going because we can simplify that, 2 plus or minus 4i over 2. My question is, are you finished? No, you can simplify it a little bit. So don't forget, if you're going to simplify this, you can't just start crossing out the 2's and say those cancel. That doesn't work. If you're going to simplify it, you got to divide each by 2. Okay? So 2 over 2 plus or minus 4i over 2. So this becomes 1 plus or minus 2i. And you can leave it just like that. There's 2 answers there. What's one of the answers? One of them is 1 plus 2i. That's one answer. And the other one is 1 minus 2i. And you just leave it like that, okay, in A form. A plus bi form. Okay, so let's talk about this one. If we are going to set it equal to 0, my question is do I want to move the 3p plus 8 to the right side? Or do I want to move the -p squared plus 5 to the left side? And I'm going to choose this to move over here. Can you tell me why? Because I want to make sure that my p squared is positive. So I'm going to put my plus p squared over here, and then my 5 comes over and he's negative. And I just line them up with what they match with. So this is going to become p squared plus 3p plus 3. Okay, go ahead and hit pause and try it. A equals 1, B equals 3, and C equals 3. So b squared minus 4ac. So this is going to be 3 squared minus 4 times 1 times 3. So you can put that all in your calculator. And I believe that's going to be -3. So that tells us what kind of answers. We were going to have two imaginary answers because of that negative. Because when you take the square root of negative, it's going to become imaginary. So x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So the opposite of b was going to be 3 plus or minus the square root of negative 3, all divided by 2 times 1, which is 2. So my question is do you leave it, do you keep going? Can you simplify the square root of negative 3? And there's only one thing you can do with it. You can take out a negative. So this is going to be 3 plus or minus I times the square root of 3 over 2. Can anything simplify? Can you factor out a 3? No, because one's on the outside and one's on the inside. So I would say at this point you are done. But again, if you can simplify this radical in any way, shape, or form, you've got to like break it down or take the I out, or if it's perfect, keep rolling with it to simplify. All right, so I feel like we're getting close. I feel like this might be our last one. Let's check it out. So x is 1, negative 1, and 6. So b squared minus 4ac, negative 1 squared minus 4 times 1 times 6. So 1 minus 24 is going to end up being negative 23. So again, here's another imaginary. So negative b plus or minus the square root of b squared minus 4ac all over 2a. So the opposite of b would be 1 plus or minus, and I'm going to go ahead, like if you want to, you can go ahead and simplify it while it's over here. So that way you don't have to do it twice. So this is going to be I times the square root of 23. And again, if 23 could factor tree down, you would want to do that. So we will encounter those types of problems. And 2 times 1 is just 2. So here's my question. Do you need this one? Like sometimes you can just take the ones off and you don't need them. But I'm going to tell you, you need this one because we are adding 1 to I times square root of 23 and subtracting 1. So when do you not need a 1? If you're multiplying 1 or you're dividing 1, you don't need the 1. But if you're adding 1, that says 1 plus or 1 minus I. You've got to have it. So there's your final answer. I don't think it can simplify any further. I don't think you can break it down. So I think you're done. Oops. So I think I'm just going to not do this one because I think you've got the hang of it. And yeah, that's the end. So we're good. We will address more of these when we get to class tomorrow. So there you go.